xi. So basically the sample depends, so for sample likelihood depends only on the summation xi square plus summation yi square and summation xiy. So therefore, like if we consider the triplet summation xi square yi square and summation xiyi, so that is a sufficient statistic for rho, which is correct. Now if we consider the third statement, like summation xi square is an ancillary statistic. So if we consider like marginally this xi follows normal 0, 1, so that means this does not depend on rho. So that means this summation xi square, this follows chi square with n degrees of freedom, which is independent of this rho. So therefore, like summation xi square is an ancillary statistic because it is not dependent on this rho or unknown parameter. And in the similar way, if we consider the joint distribution summation xi square comma summation yi square, this also doesn't depend on rho. For example, if we consider the covariance of xi square and yi square, that is expectation of xi square yi square minus expectation of xi square into expectation of yi square. So which is nothing but 1 plus 2 rho square minus 1, which is nothing but 2 times of rho square. So if we consider the covariance, so the covariance of summation xi square comma summation yi square is nothing but 2n rho square. That means it is a not an ancillary statistic. So statement D is wrong. And if we consider statement B like says that this is not a minimal sufficient statistic of rho. So which is correct because we can compress the two sums into the sum of like summation xi square plus summation yi square without losing the information about rho. So the minimum sufficient statistic is summation, like we can write the minimum sufficient statistic as summation xi square plus yi square comma summation xiyi. So therefore this is the minimum sufficient statistic. So second statement is also correct. So option D is the correct answer, which is not necessarily true.